Hey, everybody. Welcome to episode 6 of our podcast, Innovating the Industrial World. I'm your host, John King, and CEO of Cross, and I'm here with my really good friend, Brian Page. Brian and I go way back with some work we've done in high school robotics, but that's not what we're here to talk about today. We're here to talk about what we're doing in the flooring industry. So, Brian, why don't you introduce yourself and tell folks what you do?
I'm Brian Page. I obviously work here at Cross. I've been in manufacturing, process development industry now for about 40 years. It's been a long time. And I've landed at Cross where I just get to do a lot of fun stuff.
We get to do some very cool things. So we've done some awesome things recently for the flooring industry. Why don't you tell us a little bit about how we got started and what all it is?
When we approached the flooring industry, the very first thing we learned is they were losing a lot of money and struggling with measuring gloss. Gloss is what you and I see when we look at our flooring in our homes. That isn't the trouble, though, because that represents a very small batch of their manufacturing. Their biggest problem is when you get into commercial sites, very large areas, and you see planks or pieces that are very shiny or very dull when they're supposed to be
they
the
don't
opposite.
match,
Or, half the room looks different than the other half of it.
And what's funny is I remember one of those conversations a long time ago with them, and it started off with, okay, show me where you're having some of the most issues quality-wise. So the big chunk of what we do is help people improve quality. So
Right.
I think that's where the conversation started. So
It did.
how did that, tell us about what are the quality issues around gloss?
Well, when we got into the plants, we started looking at their processing and their manufacturing and how they sample it. And what we very quickly learned was the industry at that time was simply taking a spot sample. So they take a large piece of flooring every 30 minutes, put a handheld gloss meter on a spot, and write that down, and that's their quality. We learned very quickly operators could miss the issue. They could get a different answer no matter where they put it. Plus, they were sampling every 30 minutes. A lot happens in their manufacturing process in 30 minutes.
And you may have multiple pieces in a very large area, right?
Yes.
If you're building a building,
Yes.
you're going to have a cafeteria or something that's going to have more. It ain't going to be one piece.
So what was present, what we learned, and I'll get into that in a minute, what we learned was there are a lot of process upsets that they knew were there, but they never had a means of detecting them. And if they could detect them, they could compensate for them. So one of the first things we did was, we talked about gloss. We knew this was new to Cross. This was something the industry was familiar with, but they didn't have any way of doing it continuously. So we searched the market. We found a variety of gloss meters, but only one of them that would really work well in an industrial environment in continuous use.
Yeah.
So we got a hold of a sample. We took it to the customer. And I remember that day when we mounted the gloss meter over their flooring as it was passing by.
Yeah.
And I watched the scope on the computer and I thought, oh, well, it was a nice try, but I don't think this is working because it was very noisy. And it was at that point I turned around and I looked at the engineers staring in amazement at the data that was
the first
there.
time they'd ever seen it constantly. Yeah.
Exactly. What I thought was failure because, I look for patterns in data, and I didn't see a pattern at first, but they pointed out to me, this is happening here, this is what's happening in the process, this is what's happening side to side. We always knew it was there, but we never had a way to measure it.
That's awesome.
So that led to, yes, we want this.
Yeah.
Then we basically integrated that into a computer system, a continuous data collection system. So they went from sampling one spot every 30 minutes to continuous.
So what kind of technology are we using in this gloss meter?
The gloss meter basically is a light that is projected onto a material that you want to measure the gloss of at an angle.
Okay.
And there are two ways of doing it. Handhelds basically send in light at an angle, and they measure the direct reflectance. And then they sort of make up a gloss number. Gloss isn't necessarily a precision measurement.
Got it.
It's kind of a somewhat of a made up number because you're just looking at how much is reflected. The example I have seen and given is you could have a matte finish like a wood table, or you could have a tray of ball bearings. And if you measured gloss in that way, you'd get the same number.
Got it.
So,
so we have to create more variation. We have to know more about that and characterize it a little bit more.
And really, the gloss measurement, and once we all understood this and the value to the flooring industry, when you measure gloss, it is basically specific to the context that you're measuring. So if I measure gloss on a tabletop and give you a number, and you go measure gloss on your car and give you another number, those are irrelevant. It's only to the quality of the paint on your car. They would, particularly measure, or in the flooring.
And this is on wood, obviously not carpet, but is this wood or vinyl? What kind of flooring?
Oh, the flooring that we have these deployed in currently is all vinyl and luxury vinyl flooring.
Got it.
Mostly laminated and getting into extruded type vinyls.
So how was it able, when they were measuring gloss, the engineers are going, oh my gosh, now I finally get to see this. Are they able to do anything about it? Are they able to control it?
Yes. The very first system that we put in, one of the goals of that project was to also live stream that data to their data collection system, their SCADA. Mm-hmm. So they're plotting it now. So they have displays for the operators to see, and the operators can now watch and see the trends so that they can adjust the process in real time, not waiting for that 30-minute. Making 30 minutes worth of scrap is very, very costly.
Which is what they were doing before, right?
Exactly.
So being able to measure this and measure it consistently, were they able to control it?
Yes.
And if they're able to control it, lot less scrap.
Correct.
That's the real sort of tangible, really dollars and cents about the value associated with it.
Mm-hmm. Not only were they able to control the bulk measurement, like in web, because these floorings are all produced in a continuous web and then cut down later on in the process.
Yeah, how wide is this thing?
Depending on the customer, anywhere between 1.5 to up to 2.5 meters wide.
Oh, wow. Okay.
So what we quickly learned, because we were scanning the data across the web, that we could provide data useful to two groups. Downstream, or the product people, mm-hmm. can take our data, and we build this into our systems where we break up the web into lanes. So they know their web is so wide, and they know how many planks or strips they're going to cut out of that.
Okay.
And they tell us. So we give them the ability to program or enter the amount of lanes that this has. So now they have sort of an indicator of what kind of variability they can expect plank to plank.
Got it.
The other subdivision is for the process people. Now, because you're producing a really wide web, there are upstream processes that can't do it continuously. I mean, they have to break it up into zones.
Got it.
So there may be zones related to pressing or laminating the material together, different pressures and temperatures. There are certainly
they all have an impact on gloss. Yeah.
Exactly.
Yeah.
They have different laminating temperatures. They have different curing zones. These are all, terminology from the flooring industry. But the upstream now not only needs to, say, set a bulk variable to control the gloss inline or in web, they also need to vary process settings across web so they can get consistent gloss across the web and across all of the planks.
Right. And so that big deal is for when they put it on the floor and it's installed, the customer goes in and looks at it and goes, oh yeah, that looks consistent, because they would have problems with it being inconsistent before.
Yes.
That's awesome. And so we put this in, they're able to control the process a little bit better to produce better gloss. So then they moved on to measuring some other things, right? So that was really, really helpful to them. Tell us about what sort of their next step was.
Once we developed this gloss machine, it started to, it started to spread within the industry. And we demonstrated various things to other companies, so other companies got involved. Well, then we moved on to the next opportunity, because we learned that one one customer in particular that we were dealing with at the time also recognized they have a problem with emboss. So when you buy vinyl flooring, not only will it have a coating on it, which dictates, it basically
how shiny it is,
creates the shine, the gloss, the matte, whatever it is. They also press in sort of like a texture,
yeah.
A simulated wood grain, or if it's a vinyl that represents a tile or a slate, there's a sort of a micro pattern in there.
Sure.
That also is very important to the appearance. So now we have two things that the industry wants to control: the gloss, which is kind of a chemical coating, but the emboss, which is mechanical.
Texture. Yeah, and it's so you can get a consistent
and
texture.
both of those play a part in when you lay out your floor. And again, you look across a room, the bigger the room, the more critical it is. You can see all those variations.
Because a human eye can see that stuff incredibly well.
Exactly. They want every plank, every part to look the same. And not only that, now we're getting into the manufacturing footprint conversation, where they may be making these planks in multiple plants, maybe even in multiple countries.
And they need to keep it consistent.
And they want the flooring to be consistent or to be the same. So
tell us about that journey, about how in the world do you measure the embossing pattern?
Well, that was a little more difficult. That took some time and a little bit of inventing. Right now, the flooring industry will take a sample, and they'll take it to a lab, much like many of our labs where we have profilometers. And they'll measure very precisely the contour and the shape in there. But you can imagine that's not very useful process data.
Yeah, and what I can tell the audience is, for the folk, we're in a precision measurement group too, and Brian works in automation, and in the precision measurement group, he's talking about a profilometer, and that takes like a probe and goes across a surface, and it actually measures the peaks and valleys. But doing that across a gymnasium floor would be pretty, it's not even practical.
Exactly. And the turnaround time of that, by the time you've taken a sample to your lab to measure it, you're already making something different.
So how did we figure out how to do that quickly?
Well, we started working with laser displacement and trying to measure the surface with a laser. We ran into a lot of difficulties, and it took a lot of experimentation because the top coatings on the flooring are clear layers.
Yeah.
There is a laminated layer, which is the wear layer, which prevents us from scraping or cutting or our dogs from destroying it, right?
Yeah.
And then there was that coating that was put on there for the gloss output. So when we first started working with lasers, and we've heard this even from various laser manufacturers that we talked to, flooring was difficult because of that clear.
Yeah.
It gets very noisy because you're looking for a laser to bounce off at an angle, and sometimes you'll be reading the surface, sometimes you'll be reading the bottom of that clear layer.
Makes sense.
So it took us a lot of experimenting to first find the correct laser, the correct laser manufacturer, to get a readout that was reproducible. So we spent quite a bit of time making sure our laser output matched profilometer. Tried to measure the exact same place and overlay them.
So we did end up using lasers eventually.
We ended up using lasers. And the other thing we wanted to overcome is the fact that if you just use a single point laser and scan the whole width of the flooring, you run into an issue where there's just way too much information. Plus, you have the laser bouncing up and down, on a very micron level on your actuator, and it didn't necessarily provide useful data. So we went to a 2D laser scanner. It's basically a laser profilometer that will give you a profile. So now we send that across the flooring and take many snapshots, and then we process that data. Next comes the challenge is you still have noise in there.
Yeah.
We would not have been successful if we only used the laser data as like the difference between the minimum and the maximum to get the emboss depth. But simultaneously, we also learned that the emboss patterns are so intricate the wood grain, for example, has deep grooves and then has kind of a micro finish.
Right.
Uh,
and we're able to sense that.
And we can see that with the laser, but what we needed to do was to turn that into useful data for the customer, for the industry. So just like with gloss, like I told you, gloss is a gloss number.
It's a number, yeah.
We promoted the idea of an emboss number, which on any given or any specific emboss pattern, and every industry, every manufacturer has a finite number, 4 to maybe 10.
Yeah.
So within that gloss or emboss, we found that we can create this number that's relative to that.
Right. So we take like what is a perfect quote unquote wood grain, and we say, okay, we're going to get that sort of. It's very similar to something we talked about earlier in an earlier episode around the golden standard. So you have like this golden standard of this is what we say is the best wood grain, and now we can compare that, make sure not only the number, but the repeatability of that number, and tell them, hey, this new flooring you're making is consistent with that, or is within tolerance of that standard, right?
That's exactly correct.
That's awesome. So did we have to start then developing those numbers?
We actually we knew that would be a very onerous project, and not only that, now we're getting into the proprietary nature with every customer. So what we did was we built a system that allows them to put in, define their flooring. They can define everything down to the part number. Imagine a manufacturer and they got 1,600 different part numbers. They can define it on that level. Some customers only want to define it on the emboss level.
Got it.
So we've given them that capability. All of our systems are computer based. So we in the computer we have a native database. Yeah. So we're collecting data
we're creating the database, the hardware, the software, the whole thing.
Exactly. So we write the programs to allow them to visualize the data, to export it to whatever quality system they have or want, and then come back and put in that I always call it the cruise control.
Yeah.
When you're going the right speed, you press the button. That's where you want to run, and you want to stay between limits. So actually, our displays have on them true classic SPC, a run chart, range chart, and we also take the data from one scan across the flooring, and we present that. So they can look at that and they can see,
So they can see across the web, we call it the web, across the width of the flooring that they're making. You have sort of an upper limit, lower limit, and they want to say that they're running in between.
Yes.
And we can show them that. So it's useful data so an operator could go, oh my gosh, I'm getting out of tolerance, I need to do something, or no, I'm good.
Yes. And
that's for emboss and gloss.
That both, yes. As a matter of fact, the same customer that started our emboss journey has a machine where gloss and emboss is on the same head.
Oh, cool.
So we're actually calculating or capturing that overlaid data. And the very interesting thing now is what we are learning. This is not industry specific, but what we are learning, and I can demonstrate to you on paper, is that emboss and gloss are not independent.
Got it. They're related. Yeah.
So that brings us all back to making all of this floor look the same.
Right.
They've got a tremendous challenge because they have this very long process line and they have to control temperatures and pressures and coating thickness and coating curing. And
all those things have an effect on the gloss and the embossing pattern. But what that has an effect on is whether or not a person walks into a big floor and goes, oh, that doesn't look right.
Correct.
That's awesome.
Yeah. And to cap this all off, because we're working with computer control, we build web servers into our controls, and all of this database data is now available to anybody on that local, anybody the company will allow on that machine network. So,
but they can also be in an engineering team somewhere and then be looking at a plant and Georgia plant and wherever.
Exactly. And they can now start comparing, to your point, plant to plant. I recently visited a site where we had machines, and I call it the air traffic control room, where you have quality and engineers all around a pod of computers. And literally at one point, several of them were watching our machines and getting on the phone, telling the operators, telling the operators upstream to make a change.
That's awesome.
So we've gone from taking this measurement that somebody in the industry needed to improve to a complete command center to control these variables on your
and I would
shopping.
suggest it's not even just taking a measurement we needed to improve, but it was a company that these customers that are saying we're having quality problems and we're having to scrap a lot of material, and that's costing us a lot of money, and heaven forbid it gets out to it. I mean, they may scrap it before it ever leaves the plant, which is expensive, but if it gets out into a customer, then that could be really bad. So they're able to control that quality a lot more.
Exactly. Well, just to give you we always like to talk ROI in our company. Right?
Yeah, we do.
When we did the first gloss project, when we first got into it and started providing continuous data, entirely up to that point, we never got into ROI because we were trying to solve a technical problem.
Right.
So the company was willing to invest to get that solution. When all was said and done, they revealed to us that all our system had to do was to prevent 12 hours worth of scrap, and it pays for itself.
That's amazing.
So how do you calculate an
so
ROI
we're all
of 12
geeking
hours?
out on the technical thing, and we're solving technical problems and business problems at the same time.
Yes.
That's kind of what we do. That's what we call innovating the industrial world.
Agreed.
That's awesome. Well, that concludes episode 6 of Innovating the Industrial World. If you've liked what you've heard, click like and subscribe below. If you have any questions or comments, certainly enter them into the comment section. And if you want to learn more, go to crosscode.com on the automation team and the precision measurement group, and you'll see the specific solutions, and you can learn a lot more about how we solve those problems. Brian, thank you so much. This is awesome.
You're welcome.
Cool beans.
Thank you.